So, first of all, Buxton, thank you very much. And in a way, I like that font better than the free doctorate degrees I got. But first of all, it's a really pleasure to be back at KAIST again and to be in Korea. So I really appreciate it. KAIST has changed a great deal since the last time I was here. So I have a request. I know not everybody here speaks English as their first language. So please, if I'm going too fast, do that. Just, okay? Tell me to slow down. Second, if you do that, that's going to tell me, what the hell did you just say? What did it mean? Even if you speak English. Sometimes I'm not clear. And so the first thing I'll just say is that it is interesting to be back 10 years since this conference began, or the roots of it. And that makes it a pleasure, but it also made it more work. The problem was I had to go and look at my slides from 10 years ago to see if I'd learned anything in the last 10 years. And that's the scary part, because actually the answer is yes and no, and in surprising ways. So I'm going to refer to that talk a little bit. I don't expect you to remember it, but this is a slide from that talk. You'll find a couple. And in it, what I was really trying to talk about is this notion of working in an ecosystem, and the nature of the ecosystem. And in fact, the architecture of the ecosystem is almost more important than the architecture or design of the objects or things in the ecosystem, including people, including things. Is it possible to turn the microphone down just a little bit? Great, thank you. And the other part is that how I think about the ecosystem has changed, and I'm going to try and go through that. And for that, in my title, I talk about this notion of ecological intelligence. And I take this from Jean Piaget, who's one of my favorite psychologists. Now, mostly he's known as for child development, but he does have this definition of intelligence, which I think is a more useful definition than that's typically used when we talk about machine intelligence and machine learning. And so the definition he has is the ability of an organism to adapt to a changing environment through the complementary processes of assimilation and accommodation. But the key word here is adaptation, adapt. And the ability to adapt to change, whether it be, well, in any sense, any definition of change, is, I think, the thing that we need to concentrate on more. Knowing that word is more important than knowing like deep neural networks. And in fact, a lot of machine intelligence does not help very well in that. I'm not saying it's not important, it's essential, but it's not sufficient, and this part is neglected, and that's what I'm going to focus on about intelligent systems, adaptation. So this slide was from the 2009 Keynote as well, and I talked about, in terms of large displays, that we need to look outside of the digital world and think about information displays and interactive information displays in general, and just say the digital portion is a newer and a smaller subset. Important, but we can learn a lot. So this is just big posters, and you're sitting here on the side looking at them, and they're just for advertising. But they're paper displays. They're paper information displays. So then I showed this. This was part of that same slide. It's a shot that I took in, I believe it was Salzburg, but it might have been Vienna. But here, it was the same thing. And in Sweden and Stockholm, they had this at least 10 or 12 years ago, using projections. And so you can see right up, there's the projector. Because it's dark in the subway, they take advantage of the darkness on the tracks so that you can project, and therefore they had dynamic electronic advertising that changed by time of day. But basically, it's the same concept, but this is an early intrusion into public space. So this is a slide that I didn't show then, but this is actually from Korea. And I'm not sure if, has anybody here experienced this in Seoul? Anybody? So, yeah. So this came from Tesco, which was an English supermarket, in combination with the Home Plus stores here in Korea. And so this is the same as what we saw before. It's a paper display. These are the walls on the subway. This is the subway door. This is the train. So the first thing is, by the architectural space, instead of having coming to the edge here where you can fall in, there's a door, and the trains come along here. And in London and most cities, the wall is over there where the advertising is, on the other far side of the train, and there's no wall here. But if you have a different architecture in the physical space, the wall is here, like in most airports, and you have to wait by the door, and then there's a door to get to the door of the train. And so all of these have barcodes. And so you can take your mobile, walk up to the paper, and that's a huge display, and do your shopping. And then by the time you get home, because we all know how long it takes to get anywhere in Seoul because of the traffic, your groceries are waiting for you. And so it's a really interesting form of a browser using the visual language of a supermarket, employing just a phone. None of it needs a battery or any electronics. Everything is in the mobile. But it is absolutely a brilliant concept in terms of an interactive surface. But it doesn't mean it's an economic or commercial success. But it's really interesting. And for me, whenever I see these things, I have to take them, I collect them for reference points. What can I learn from this? But the main thing for this, we saw two things where we had electronic displays, and one paper displays and the other in subways, and here's another one, and they're completely different. And the electronic display and the first two I showed you have far more in common than this with the other two. This is far more interactive, and it's mostly paper. So this is one that this is a real system that back around 10 years ago, I was in Cannes in France at the advertising. It's called the Cannes Lions. It's where the advertising industry comes. And this is a Coca-Cola machine. And the whole front of the Coca-Cola machine is a big LCD with sensors. And so there really is that stupid little penguin throwing snowballs at you from inside the freezer. And so people are coming up. Listen, people were putting money into this even though they knew there was no Coca-Cola there, just to get the animation. It was amazing. But this notion about, again, what is an interactive surface? What is a display? What is advertising? And so on and so forth. And this was done by a company called Sapient. The creative director was a guy named Freddie Laker. But it's really interesting to me just watching how these things are out there in the wild and all these other manifestations, and they're very far from what most of us spend most of our time doing. And it's really important to see how can we learn from these. Now, these next slides are from my talk from 2009. And so these are my predictions towards the end. And so this is where I have to stand up and confront my own dogma and whether I was being crazy or egocentric or just naive. And so I said, on a ubiquitous digital media, that the diversity of web browsers tomorrow will match the diversity of ink browsers today. So when I'm talking about ink browsers, I'm thinking about anything where I can draw, I can mark, and so on and so forth, and that they're going to go to different form factors. So in many ways, that's kind of true, but you have to give me some leeway and to say, well, web apps could constitute as web browsers and so on and so forth. And it's not really true, because what we call a web browser, at least in the form of Mosaic and its follow-ons and Netscape, is different from what we think of the web now. So in some sense, there are no web browsers. So it's easy to be more diverse, because but in some sense, how we interact with web-enabled and network-enabled devices and using ink, it is starting to change, and change dramatically, but not very far. Ink is still Second, it's still not anywhere near where I'd hoped it would be or where it should be. The second thing is that, the diversity of digital ecosystems tomorrow will match the diversity of biological ecosystems today. Well, with the Internet of Things and so on, we're kind of getting there, where there certainly are more ARM chips in the world than there are people. And that's an interesting notion, that the number of CPUs that are out there is by far outnumbering the population of humans. But on the other hand, it's probably not matching the population worldwide of cockroaches or spiders. So there's way more technology there, and that's somewhat interesting. And the third one is that the social mores in the society of appliances tomorrow will match the diversity of the human society in which they reside. This is the one that I think is interesting. And I'd forgotten I'd written that, to be honest. Because sometimes it makes me forget how long I've been saying the same thing or trying to find new ways to say the same thing, so I forgot how I used to say it. But this is really interesting because the most important word here is social mores. That I'm talking about the ecosystem of digital technologies in sociological terms. That there's social mores, there's social behaviors, and there's social relationships. And in that regard, 10 years ago, that relationship was terrible. When we think about social computing, we think about using computers to have social relationships amongst people, not computers to have social relationships with other computing devices. And what I was saying there, and I really meant it, was that it's really important to start thinking about the society of technologies, not just devices, but applications, services, and devices. And that society, and what are their social networks, and what is the appropriate behavior, namely the social mores that defines their relationships, much less that ecosystem of technologies interwoven with the society of people. And recognizing even amongst people, there's different cultures. And this is the place where we want to go. So to recap, now I'm back to the new stuff. Just to summarize, there is this increasing diversity of technologies. These technologies constitute their own ecosystem. And when I say ecosystem, I absolutely mean it in the broader sense, not just biologically, but socially, and even cognitively, and so on. And they all have their own social mores, except they don't. We expect them to as users, but as technologists, we never think of that language. And we don't think about them in those terms, and therefore, every time we introduce a new device, I've never seen in the specifications the list that says, here are the definitions of the social conventions, the social mores, that define when and where and how this device should be used, and how every design decision I make is going to channel behavior to bring that about. And remembering that the greatest influence on human behavior is to control the bias of the path of least resistance. So the things you make the easiest are the things that are going to suck people down that path. And therefore, if you think there's a correct way to use things in a correct location, then by design, every bias of the user interface should bring you down that path, according to your beliefs. But you have to have those beliefs first. But before that even, you have to understand those beliefs need to be defined. So that's all fine. But I have a bigger problem here. And the big problem I have is my use of this term ubiquitous digital media. So first of all, let me tell you where that term came from. At Xerox PARC in the from 1987, I started working with Xerox PARC in the early 1980s, but I was there full time in 87 to 89. And then again from 89 to 94. I was working with Mark Weiser on the ubiquitous computing, and I'll talk a bit more about that. But at the same time, I was part of the Media Space group, which was doing video conferencing desktop. What you now think of as FaceTime or Skype, all that work was pioneered at Xerox PARC starting around 1985 or 86. And So that, first of all, I said to Mark, ubiquitous computing and media space are the same project, just using different technologies, and it should be called ubiquitous media. So I've lost that. That's not the language, but that's the language I still used 10 years ago. But it's the word ubiquitous that I have a problem with. Ubiquitous is the wrong word. And Mark got it wrong. And I'll try and explain why I think that. So this is Mark Weiser right here, by the way. And here's a group of the team of which I was part. On the live board, which was the first large screen interactive device, it was pen operated. It truly was a light pen. There was an LED on the tip of the pen, and a red one. And that's, I think it's 9600 nanometers is the wavelength. And so it was an overhead projector with an LCD rear projecting onto that, but there was a camera back there that was sensitive to infrared light with a large space so that it just tracked that. So it truly was a light pen that was working there. And it was monochrome and it was terrible. These are these Park pads, which were wireless slate devices that we developed that were pen operated. They were all networked. Remember, this is where Ethernet was invented. There's a close-up of the Park pad. And then the third class of devices that defined his article in Scientific American was around the Park tab. This one I know really well. Those two I worked with a lot. This one I actually designed the form factor. And so what's really interesting on this, I want you to notice, is its shape and the fact that there's 3 keys here. You hold it by your baby finger and your thumb. These 3 fingers are free. Each sits on top of the buttons. So it's like you can chord on it and still be able to work on the screen here. And here's an infrared sensor which actually was used for the wireless networking. And what I want to say about this is that when people talk about ubiquitous computing, they're thinking about computers everywhere, and you have everything everywhere all the time for everybody. And in a way, Mark did talk about that. He talked about places where in an office building or something, you might have tens of, in each room or something like that, you might have 1 or 2 of the live boards, you might have 10 of the pads, and hundreds of these little things that they would become like paper. And so it was scale, and they'd be in the right place, and therefore they'd be transparent. So, and that sort of, and when people talk about so-called Internet of Things, that's kind of what they're thinking of. It's just an instantiation of that. That's not true. So what happened here is this device, a company called Fitz Richardson Smith did the final industrial design. I did the specs, the layout. So it had to fit in the hand. So I'm a musician, spent 20 years of my life as a professional performer. One of the instruments I played was trumpet, and therefore I built it in the shape and the form of a trumpet. With 3 buttons, you have 7 combinations. So now, and the important thing was the hand that held it could also operate the buttons simultaneously with that same hand, which is there's not a cell phone in the world. There's one German one that I saw. I still can't find it. I've lost the reference. But there's only one mobile phone in the world that I ever saw that was designed where you could operate the buttons from the same hand that was holding it. We shaped this to fit women's hands as well as men's, so we did the ergonomics. And you could do these combinations. And in holding it, it exposed the infrared, because that's line of sight. It had faced up, your face is up. And the other thing was, it's symmetrical, so therefore it'll work for left-handed and right-handed people. So what drove my design decision to have that grip and those 3 buttons? It was that when I'm walking around by myself, this is exposed to the beam on the roof of every room that did the wireless, and I could work like this. I could look at it quickly with my other hand free, and if I wanted to, I could bring the pen and write. This was using X servers. Every one of these was an X server. But the main thing was, the plan was that when I walk up to the live board, where I only had a single pen and a very primitive pen, this then would attach and be an auxiliary, so I could scroll and do other controls to bring up menus and work the interface. So now the interface of a live board could be extended to this device working in combination, working in harmony as an ensemble. And yet, as soon as I walked away, it would be able to be freestanding, and that would still be freestanding, but less functional. So there's this pairing of devices. So it wasn't just everything everywhere scattered. It was actually starting to say these relationships that have to do with proximity and so on and so forth. So it's just like if I came here, this is kind of weird if I come really close to you, and it's even stranger if I sit down here. But I've got the same microphone, I'm the same person, I'm in the same room, the screen is still there, I've got the same control, I can still change my slides. But it's completely different. But how many of our devices know that and can sense that and behave appropriately? And so that's the kind of thing when I talk about social mores. It's not appropriate for me to come to you, and I came to you because you're a man, but if I went to a woman, if I came to you, it would be even more uncomfortable, because that's another level of social construct. Our devices have none of that. And that's why things are going to hell. So, ubiquity in the dictionary, Oxford English Dictionary, is the condition of being everywhere in all places at the same time in general use. That's the word Mark used. And by the way, when he used that word, all of us had to look it up in the dictionary. None of us knew that word. In 1988, nobody knew ubiquity except for Mark Weiser. Kind of like that. But I was trying to look up the definition because I was unhappy with what I was seeing in our business, in our industry. And ubiquity felt wrong. And so accidentally, just by searching the precise definition of ubiquity on the same page, I found a new word. This is why curiosity and going for specifics, go for the details and you'll discover things. Ubiety is the word that I want you to learn. I want you to use this word all the time. Ubiety is a cousin of ubiquity. But instead of everything everywhere all the time, it's the right thing in the right place at the right time for the right person at the right price in the right form. Because it's condition and respect of place or location. And it's really important. When you use those words, place and location, how creative are you in imagining different dimensions of place, different dimensions of location, social, relative location, what we saw there. We're all in the same room. Anybody walking in knows I'm the speaker and you're not. And that he's there to help in case I fall off the stage or need to plug in something, right? We all know these roles by location, even in the same room, even in Korea, even though we come from all different countries. And our technologies have to learn those rules. And we have to design them in that room so that when we talk about, and this is why ISS, I love the change of the name, because it's the surfaces. Everything is a surface. We've seen it now, paper on a subway wall versus these devices. But they're placed in space. And how do we design the space and take the space into account where the surfaces occur? And so ubiety is really important. And I'll give you some examples of how I use this. So first of all, architects, people in architecture already understand this because they know when they design a building the difference between a kitchen and a bathroom, even though the bathroom, they both have sinks and running water. They're very different purposes. I love this line, right? Thoughts exchanged by one and another are not the same as in one room as in another. And I believe that's true when I exchange the word thoughts for messages or statements. And one another could be one computer and another, one computer and one person, or two people. In every single entity in that social ecosystem, the superimposition of the technical and the human ecosystems, when they're making exchanges, they mean different things in different contexts. And again, how much time do we spend on industry working on those relationships as opposed to working on the gadgets themselves? And that's the shift I think we have to make. And there isn't something called cultural geography, which actually helps us learn about this. So if we actually, just as when SIGCHI started, nobody knew much about psychology or how to run experiments or cognition or learning, we realized we had to go into those fields I believe that we should have to go the same thing into sociology, but certainly into cultural geography too. That's where we can start. There is a literature, so we have a starting place. And so how do we, in teaching and in our own practice, start to bring these things into place? And one of the fundamental terms, which one of my really good friends, a sociologist, Richard Harper, taught me about, and he's one of my mentors, and I still have mentors. I sit at their feet and listen, is the notion of moral order. And this is the set of social rules or social mores which govern appropriate behavior within a culture according to place or situation. And this is fundamental to what we do. Every new device we make, we must take that into account. It's not part of our practice. And so somehow we have to start building the language. And by the way, to get that language, we can draw on sociology, and among others. And there is a place to start. And by the way, if I believe that the statement I always make about the long nose of technology, that everything is going to happen in the next 5 years is already 15 years old, then there's already examples of what I'm talking about hidden in plain view that because we don't have the correct optics, we're not seeing. And so I'm going to give you some examples of that. But key, driving all this is Ubiety. Seems to me it's a fundamental concept relative to interactive services and spaces. This is the perfect place to have this conversation. So we talk about personas. Let's start talking about placeonas. What are the places where our technology will be? And use the same type of methodologies that we use for personas. Who's there? Where are they? And where are they in all relevant dimensions of space? And same thing here, as well as wearable computing. This one I have to credit my wife because she was making fun of me. But she says, well, it's wearable computing. Everybody who's doing wearable computing is actually spelling it wrong. It needs the H. Because anything that's wearable is inherently moving to different locations. And it's not that I have a wearable device, it's where is the wearable device? Then you can start to do interesting things. And it's all about, and I mean that socially. Is it beside a mobile phone? Is it alone? Is it in a car? Is it, go on and on and on. So let me give you an example. Remember I said that a lot of what I'm saying is obvious and hidden right in front of us in plain view. Now, I'm not saying that we're stupid. No. My definition of creativity, the act of creativity is the act of making the obvious obvious before it's obvious. And the good thing about it is, if you have that type of creativity, when you have the idea, everybody gets it. So I'm going to try and prove that in a couple steps in an example that everybody knows. Take this car. First of all, we all know the rule. You, in that car, if you are going to use your mobile, it has to be eyes-free and hands-free. No touch, no look. Everything has to be typically the interface from speech. So we know that. So the second thing is, when I have my phone, which I do, I'm not in a car, I shouldn't be using it, but I can operate it. It works fine. It's all by itself. I have no car. It still works. What a miracle. Okay, so I get in the car. Now, they come together, and if I say, where is the phone? And this thing is sitting on the passenger seat. Where's the phone? You can't answer that question because that's no longer the phone. The car and the phone have come together into one entity. They've aggregated together. The only answer to that question, where's the phone, would be yes, which is the funny answer to where is the phone, yes, or it doesn't matter, it's not about the phone, it's about the conversation, or it's the aggregate. It's the car was different, the phone were different, and they both turn something new. That's the combination of the two. And it happens after they've been paired, it happens automatically. And what's really amazing about that is that when I get out of the car in the middle of a conversation or texting, 100% of the interaction language changes. Think about that for a minute. 100% of the interaction language changes when you walk out of the car from when you were in the car for this device. Second, 90% of the hardware managing the call locally changed automatically. And because of those two huge changes, those huge inconsistencies, you have complete consistency of conversation. It's always been about the conversation. It's never about the phone. So we've gone through that. Now, take this. Same car, same phone, same driver. Oh, but the car I don't own. I rented it. I'm not allowed to drive that car from Vancouver to Whistler to go skiing. If I need my phone because Bong Chung might want to talk to me about something important, or Michelle, and I have to have the speech and the ears. Well, guess what? It's not my car. And half the time when I rent a car, the contents of somebody else's phone are completely, all of it is in the car because I left it behind. Because here's the point. You notice previously I said I paired my phone to my car? That's nonsense. That's the beginning, it's not the end of the social contract. The phone should know damn well that that's not my car, but yet I must be able to have hands-free phone. And therefore, because I've put them together, they recognize, I've never seen you before. I don't trust you, but I know what I need you for. We'll have a partnership, but I will only let you take my voice signals back and forth with that, and no information changes hand. So the point here, the moral order is such that if we cannot support a negotiation of what are the trust levels dependent on the devices that are communicating this in terms of ownership, then we're going to get it wrong. And the car companies never thought that the way you connect your phone should be completely differently. You should have a guarantee when it's not your car that you can still not kill somebody, but you also will not leave anything in the car, and the car will leave nothing in your phone. That's the social contract. But we don't think of the social contracts because we don't think about Ubiety. That is Ubiety personified. All of us have had those experiences, and it's still not in practice. So it's all about kinship, again, a sociological term. So here's what's going on here. Technically, we want seamless aggregation and disaggregation devices. So to go from here to there, back and forth, that must be a seamless process. That's what happens in the car, except for the first time when you make the introduction. After that, I know you, and I know our relationship, and we're going to behave accordingly because we understand the rules, the moral order. And at the same time, in terms of functionality, I need a graceful augmentation and degradation of performance. The speech recognition is much better in the car, for example, with my phone than it is when it's not, because it's more important, and there's more computational power in the car. 1/3 of the cost of your car is in the computer systems. So what's interesting here is that as I aggregate the phone and the car, I augment the speech capabilities. That you'd expect that. And when I disaggregate, I degrade the speech because I could rely on the hands-on and eyes-on. But what's less obvious is the fact that when I aggregate, I also degrade some things. So you cannot play Angry Birds in your car. You cannot do an Excel spreadsheet. Probably 90% of the things you can do with your phone, Instagram, all that, you cannot do while you're driving. So the way and this is important because you know by Ubiety and the moral order of that place what you need and what completely violates the principles, so I can bury all of that functionality, hide it, and that's how I avoid complexity when I bring things together, because I only expose what's appropriate to there and appropriate to your expectations and matches your expectations. And so, and yet the other things, things get stronger. And so this is the relationship. And so what we're going on here is that between the technology and the function, the qualities are really important over here, seamlessness and gracefulness. And the critical means to attain that is by how much we anticipate and know the rules that govern what functions and what capabilities go along which of these arrows, and how do those transitions work. It's about the animation, because remember Piaget, it's about adaptation. What we see in the phone coming to the car is adaptation, beautifully executed, compared to almost anything else with our digital technologies, but it is a rare exception, and everything should be have that type of relationship and that seamlessness of flow, gracefulness, and seamlessness. And that's the argument here. And it is precisely those considerations which let us get into this, that provide the flex that if you know this word of Csikszentmihalyi, I can never say this, Csikszentmihalyi, who wrote this book, Flow. If we're trying to achieve flow, so there's no speed bumps when I'm going along. I don't have to go like that. I can just glide, And this is how we do it, by getting those transitions right, so I don't have a disruption into my task. First order, I want to talk to you. I don't want to operate a computer in the intervening period to disrupt what I was thinking about, because I'm old and I can't keep a train of thought at the best of times. So this is really important. So here's what lies behind here. There's this thing called God's law, the complexity barrier, or the threshold of frustration. HCI, UX Design, has done a spectacular job of reducing complexity of any device. Let's be clear. The iPhone changed everything. It's changed the expectations of consumers. It proved to the rest of the industry what was possible. And if you can't do better or as well, then you have no business making products. And so we're doing a really good job of reducing the complexity of applications and of devices and services. There's still really bad design out there, but I'm talking about the people who are going to be in business in 5 years. But what's the problem? The more devices, the more we can reduce the complexity and increase the value, the more people are going to buy. And the more devices are going to be out in the ecosystem. So the ecosystem is growing like crazy. Now, what does that mean? It means that we're going to hell if we don't figure out because what is inevitable is that, and what we forget, is that no matter how simple, desirable, affordable, and useful every device is, or every application or every service, together they just go way up there. And when we cross this line, the ecosystem now is in chaos. And we're already there. We just haven't hit it badly enough. And we've got to wrestle this down. And the way to do this is if things work together and we follow these rules where we reduce complexity as we bring new things, we reduce things, but it's dynamic and it adapts to place. So I only expose the complexity that's relevant to the task at hand, for programmers as well as for users. So the key, now what this comes down to is the whole issue of economics. So there's somebody named Roland Coase. He's a pretty interesting guy. He's an economist. He won the Nobel Prize in 1937 in economics. He wrote a book called The Nature of the Firm. But this is the term he coined, and which underlies his theories, is transaction cost. So he basically took companies, let's say in Korea, let's take LG and Samsung working together, and what's going on there. One of the strongest things let's look at the LCD industry and televisions. One of the key things is what is the cost of every transaction they make in terms of design, manufacturing, distribution, advertising, and all of these other factors. And where you get the efficiencies throughout that whole thing is where one will beat the other. And because there's too close together, they're such tight competitors, each one makes the other one better. Just like Apple made Microsoft better in terms of design. Let's be clear. My job became way easier after the iPhone. Because when you were making more money and you've got market domination, even if your products are second rate, they're not good, they work, but they're boring, why would you spend money to make things better? Because you got a competitor who's just ate to your mobile business, for example. Competition is a good thing. But transaction cost is one of the prime levers. And what I'm trying to say is that we have to be economists. And so for every function, every feature, every device, every product, every service, we have to specify it, including what is the cost and not just what is the benefit. I never want to go to a meeting before where somebody says, have this great idea, it's a fantastic, look, this is how great it's going to be. I have to ask, at what cost? And also, at what cost to whom? And how is that cost structure broken down? And most importantly, what are the currencies in which you measure cost? So I'm going to give you an example that how if you take that, you can make a huge difference. So this is a product I designed with my team at Alias Wavefront back in around 2000. And this was a 53-inch plasma panel with a touch screen, single point, and it was for automotive design studios primarily. It was for design studios to sit in the studio, but also in the executive offices so that you could speed up design reviews. Because it turned out that in automotive, 30% of the design cycle was spent waiting for design approval, which is insane, because there's nothing you or I can do as HCI or user interface designers that are going to improve the performance of a group by 30%. So that's what this was for. But it had to be used by the executives, by the designers, and they had to be walk up and used. So here is the specification. And this is not BS. We built a prototype that showed the behavior, what it should do, using just bubble gum and duct tape and whatever. There's not a line of code that could go into the product. But it was the behavior, the fidelity of the behavior is what was important. But the specification to the engineering team who went in to build this was every employee of General Motors, from the CEO to the janitor, must be able to learn 80% of the functionality in 3 to 5 minutes, and with a week of not using it, have a 90% retention of what they learned. And if you do not meet that specification, that is a stop ship bug. That product will not sell. You will not go to market. We will hold it up until you meet the specification. Now guess what happened? The engineers said, okay, we get it. This is what you want. This is the specification. But you're stupid designers. You're stupid researchers. What do you know about this? We're engineers. We're really good. And guess what? They are. And I respect that. And they did exactly what a great engineer would do. They wanted to beat the specification. So they came back 3 months later and said, you guys you're not that good, We took this out and this out, and we could do it even faster and with a better retention because we got this done right. Because as soon as you set that down, but if we put the specification in terms of this feature, that feature, that feature, that feature, you know what the engineers are going to do? They're going to add new features that they think are better, that make your stuff better. Which even if they're really good, they're going to change the complexity and the design and the whole design language. So you control it. So I'm just saying, if you specify in economic terms, you will have your engineering team work with you, not against you, and they will do even better, especially if you talk back and forth during that process. And so if we go, here I'll give you a quick piece of this. Oops. All right, you're not going to play?
Now to explain that, I'm going to use the portfolio wall as an example. Now the portfolio wall, to remind you, is this large format display that lets you view a number of reference images just so you can keep track of them. And it lets you interact with them in simple ways. So I can select an image and blow it up and see it in high res. I can rearrange things in different orders if I want. And I can, having selected one image, make a presentation to the next one, to the next one, to the next one. What I want to say about this is that my relationship to the board is very similar to what you would...
Okay, because of time, that's online. You can go through. But I want to point out, that's 2000. That's 7 years before the iPhone. Okay? All of that was possible. And that was commercially available in the automotive and design industry. So you probably don't know about it, but that's for good reason. But the major thing about it was there were different versions. And so if you go to my YouTube channel, you'll be able to see the portfolio wall with the mobile devices. And if you're working that way, you can annotate things, and you have one wall in Detroit and the other one. Here's the company. There's a company that had their design studio in Orange County, California. The headquarters for the company was in Japan, but the headquarters of that company was in Detroit. And the problem was, how do they keep track of the designs? So if you have the same board in every location, the executive in Detroit can walk in, apart from the desk, and make annotations, make notes, and then ship it back, and you have like 24-hour turnaround instead of 3 weeks. And furthermore, if you can connect the boards, and so you can actually say, hey, I go on a meeting, okay, let's just talk and we'll go over the design together, we can be working on the same board simultaneously. And so that was already being used in the industry as early as 2001. And so the main thing is that also within the design studio, every designer, there was a big projector up like this, so that was a public one, and you could take your mobile and wirelessly throw things up and take things down and examine works. So you had a completely different interface using what was Wi-Fi didn't even have that name yet. It was still called 802.11, and you could just go like this, and you could use this like a touchpad onto that like a big remote screen, but everybody had their own device. And that was, again, shipping in 2001, 2000, yeah. And so you have very different instantiations in the design studio versus in the executive office, but it's exactly the same code, but different user interface techniques and different devices in every situation. And it was designed that way. And I used that for PowerPoint. I'd put it on my laptop, and that's what I'd use for doing presentations. But the main thing was that you had consistent expectations in terms of the form factors, but inconsistent with respect to the modalities, because the public one was different than the private one, and the one you'd use in a presentation, for example. And it also worked within the 2-foot distance, a 20-foot distance, or even a 10,000-mile difference when you work these things together. It was designed as a social collaborative tool to facilitate the communications amongst executives, engineering, and of different parts of the world, and so on. And the key thing was the transaction cost was fundamental to the design of the product. And so it was really simple, 3 to 5 minutes, or it doesn't ship. And so just to say this, hopefully this will work. It even worked in 3D to emphasize what I just said. So here we've got a 17-inch LCD on a boom, and so you move it around, and so you can actually walk around a 3D model, and it's like augmented reality, but it's on here. And you could also annotate right on the device. You could speak while you're going around to give commentary. And you're pointing, your marking, and your speech, and the camera movements would all be recorded, and then they'd be attached to the design. Anywhere in the world, you could just get that and play back as if you're looking over the shoulder. But if Buxton and you and I were sitting together, we could all see this together, which you cannot do in AR. But this is a form of augmented reality. But the most important thing, that is the portfolio wall. The same thing you just saw there. It's another manifestation. And if you know how to use one, you can use that one and this one, because there's a common interaction language. You compile once, you execute, and it's sentient. It senses what the form factor is and adapts its behavior just like your phone does when it goes in the car. The behavior just, and so that the developers don't have to keep doing things over, do these different versions. So I want to give you an example that's closer, because I talked earlier about ink is really not where it needs to be. And everybody can tell you that, I can type faster than I can ink, that I can write. And of course, yes, sometimes. Everything's best for something and worse for something else. Nobody that you know can type 2 squared does not equal 22. Faster than you can write it, because nobody knows where the not equal sign is on the keyboard, and it takes too long to get the exponent, right? So don't tell me you can type faster than you can write. So it doesn't mean ink should be used everywhere, but it tells you there's a really good example. But here's another one. This is PowerPoint, right? So this is the simplest PowerPoint slide you can imagine. All it does, it has the word wow right there. Gee, wait, wow. Okay, here's the point. Every one of you has made a PowerPoint presentation. Okay, so how many steps would it take you to do that? How long would it take you to do that? how many adjustments to get things tuned? And by the way, how long would it take you to teach a beginner how to make that slide? How many options on the ribbon would you have to use? And when you're moving it, you're going to have to keep making adjustments to get it there. So this is what it takes. That's the task analysis. These are the primary tasks along here, and then there's these secondary subtasks down here. Now what this teaches you is that everything's a hierarchy. And the entire hierarchy of tasks, subtasks, and microtasks are all exposed to the user. That's what you have to know. That's all the code you have to make. That's all the UI you have to fix. Now, if you just make better icons or you just change the layout of the menus, you're simply putting lipstick onto the pig. It's still a pig. So, can we fix that? Can we really make that? Because I don't know how many of you had children, but all I know is that when you were 5 years old, you could do that without me teaching you anything. If I give you this pen, I give you a Surface Studio, you could do that, and you just do this. So that's slow, and even that only took 5 seconds. Okay? Now, what's going on there? Well, if I add some AI now, it just does that. Which would you rather do? You can leave it inky if it's a sketch, but if you want to do the final thing, do that. Because what you're doing is you're specifying the text, like the characters, you're specifying the font size, you're specifying the location, and you're specifying the angle. And if you use pressure, you can even specify whether it's bold or not. All in one gesture. So what happens there, if you have to think, is there's only 4 strokes and a dot, and a little AI, and you get the characters and all this stuff that just like what I just said. So if you did the analysis, that's the complexity. But in fact, all of that's hidden. It's like it's just one thing. And that notion of collapsing the underlying complexity into a single thing is one of the ways that you surface the complete attention on the content. Just like in a car, you focus the complete attention on the conversation, and none of your attention is on how do I get there. I'm not moving from here to here to here to here. I can work at the speed of thought. I can work at the speed of creativity. And it's really fascinating if you do that. But here, there's an example that very, very, very different technologies, very, very different input-output devices can be used to get exactly the same result and actually get it an order of magnitude faster. And that's what we have to start doing. We don't want to keep making better interaction techniques. We want to figure out where do we reduce complexity of the underlying task as opposed to the things. So which one do you want? It's really simple. You get at least a 7-fold increase, 7 to 10-fold. And so here's where we get it wrong. This is a slide from 10 years ago. The expertise was in the desktop. But where the future was off on these big screens here and the mobile devices there. And what we did, as a consequence, because our expertise was here in the middle, we tried to put the desktop onto the mobile phone, and we tried to put the desktop on the great big display. Well, that was a complete disaster. And so it just makes no sense. So what is obvious is that once I go beyond 55 inches, I can't reach the far side over there. And I certainly can't reach the top. So what do I do? So the observation was that we were seeing things back to front. The observation is that this size, this form factor, and this form factor have more in common with each other than anything in between. Okay, why? Because here, the screen is too big for me to be, it's not in human scale. I can't reach the UI. If you have Chrome here, the ribbon up there, it just will not work. There's too many pixels. They're too big. And over here, there's too few pixels, so I still can't have any Chrome or UI elements on the screen. I need the screen for data, for my task. I don't want any function here. I want to see what I'm working on. That's exactly as here. And then it turns out that if I design for that and that at the same time, the same thing will work on any of these form factors. And it completely changes how I think about design. And so here's one example of how you can do that. Is that this is Michel, who's over there. You'll meet him. But this is like a painter's palette. You can stick your finger up there, and your ribbon comes right to you with your non-dominant hand. And you'll notice that this is exactly like the ribbon in PowerPoint. You recognize it. So the learning curve is almost zero if you do it properly. But then now is this going to play properly? No, so this is sick because I'm running out of time and I don't want to just
touch here. I have my own menu, and now if Edwin touch, he has his own menu. And then what we have is here, you have a radial menu that's like a ribbon. You can imagine like the ribbon in Office. So I can switch between different type of menus by just doing a gesture. By default, what we wanted is to have no Chrome on the UI. So now let's say that we are brainstorming about something. So maybe I draw something. And maybe I write like people, and he's writing something. And then maybe I draw a curve. And write slope, and so on. And then what we can do is to go back to our menus. And then we can decide, like together we can collaborate and just, for instance, change the strokes. So here we can even disagree on the color. No, I prefer blue actually. I wanted to maybe trace a line or do something different. So I touch again here. And I have another type of menu. And here I can use two hands to actually, with bimanual technique, I can place and size a line. I can do the same with a square, for instance. And
okay, so that video's online, so you can check this out. The main point is that they both have their own colors, their own palette. If you have a paint pot down here, who's controlling which pen? How do you know it's there? No, you have your own right here. You have your own OneDrive, so you can actually get your own files, the personal files here. And what I want to say is that this type of UI will work on a mobile. It'll work on a Surface Pro. It'll work on a Surface Hub or any form factor. Now, you still need a desktop, but all of those techniques will also work on a legacy laptop with no touch screen, a trackball or a touchpad and a mouse, because that's actually where we invented them back 25 years ago. For many of them. So everything's best for something and worse for something else. Key is knowing where, when, which, how, why, and so on, and for how much. This is all about Ubiety, and things have to adapt appropriately. In those form factors, I want it to be. We are working. This is what Michelle, Ken Hinckley, myself, and Buxton, our team, is doing. We want to write the code once, and when you launch that application on a device, it knows what the resources are, and it automatically utilizes the resources that are there and presents it with the interaction language that are appropriate for those resources. And it's really important. And it's exactly the same code, whether it's on a mobile phone or on an 84-inch hub. And furthermore, that automatically will let you have two people working on the same application at the same time. And the application programmer only programs it once. And furthermore, that if you're working together, if two people can work on that one big screen, then two people should be able to work on that same application with Buxton in Korea and me in Toronto. And Michelle can be the third one in Redmond. That the applications we use when we work remotely should be the same applications we work when we're together, because we should be most expert in the things we work with when we're collaborating. And that's where we're the least expert. We're most expert in things we work in alone. Make them the same thing, you get rid of that problem. So I'm running out of time, so I'm just going to say we saw from the wow that these things all tasks are compound tasks. They're in this hierarchy. How do you collapse a hierarchy? There's a paper by Phyllis Reisner that is what founded my knowledge. Is a paper from 1981. It's really good to know these papers. She's highly underrated in the field. She's one of the most influential people on my thinking, and there's a paper of mine if you want to get my analysis. It's on my website, but it's just says chunking and phrasing, and I'll tell you that. So just a quick summary of where we are. this is the room where we work in our laboratory at Microsoft. And so there's an 84-inch Surface Hub here, for telepresence, a drafting table, which is a 55-inch, and another device there. And so we can have a remote presentation, we can have a shared whiteboard, we have a shared drafting table, a presentation display. But this is all great. And by the way, that had more display than any office space I've ever been in, and yet it looked less cluttered than any workspace I've been in, because things were in the right place. They were well organized. But here's the problem. This is a 55-inch, it can tilt, go that way, I'll show you in a minute. But Ken is working here. There's space between him and that wallboard, so he can it's just like here. He's working here, and the 84-inch thing is here. So if you two came into my office, I'll just move the stuff over here, and we'll just work here, and we can work on the whiteboard. But how do you get the stuff from here? How do you get stuff from there to there? Well, guess what? We haven't solved this problem. With a touch screen, you cannot drag something from here to there. You hit the boundary, and there's no handle. That's a kind of Microsoft's problem. But you've got those problems have to be fixed. And furthermore, if you're trying to connect with Miracast to another display, the stupid thing is that Ken is logged on here. It's his computer. He's logged on there. Same person. It's like the car. But they don't know about each other. So if he wants to Miracast, he has to get up, walk around, and accept the connection from his own machine, these things, we just haven't thought about the transitions. And we've got to do a lot of work. But if you don't live in the space, you're not going to get it right. But here, eye gaze, it's just making sure that you have a wide-angle camera on the remote so they can see the people and the context. You need to do that sort of stuff. And tune it. We have to live in this. And when you go around behind, you need to be able to take the work with you. And you notice that because of the wide-angle view, the remote person is going to see you move, and therefore they're going to change the gaze, so you maintain gaze awareness. And this is just to make this thing going to finish up here, is to say this is the same device, the same drafting table that we put together, and every one of these postures of the 55-inch display are completely different. They need completely different design constraints. You can't use a dial on a vertical thing. It'll fall off. You can use things like tangible devices on the table, but they all have a baseline. This has no baseline. And, oh, by the way, these all can rotate to aspect ratio as well to make things even more complex. How do you design that? And I'll just show you this. We're running out of time, aren't we? Yes, okay, I'm going to finish up. I'll just finish up with some words. These are the things that I want you to walk away with. Ubiety, what does that mean? What is a persona? How does it relate to Ubiety? How important are transitions? And this notion of mobility, stop thinking about, when I say mobility, don't think about this. Think about the mobility of the human activity. That's the only kind of mobility that matters. And from a user's perspective, think about adaptation. That's the foundation of intelligence. Think about flow. Measure it. Think about what is the person doing and how can you reduce the transaction cost by thinking about the location and so on and so forth. And sentience. The technologies have to be able to sense their posture, their position, who's there. How can we measure these things in a non-intrusive way that maintains ethics and so on? These are all research problems. And I don't want to be here in 10 years, because first of all, I want to, be skiing or something. But more importantly, we don't need to wait. We can make everything in that room I showed you works. It's just that the transaction cost for everything is 10 to 100 times more than it should be or could be. But technologically, 80% of what I want is already technologically feasible. So I'm going to stop with this and just say, the next big thing is not a thing. The next big thing is a change in the relationship amongst the things that already exist, a change in the social relationship of the things that already exist, the things that are going to exist, and them with the people and the environments in which they live, like location and humans and so on. And so what if things just worked? What if things just worked together? What if when things worked together, they did so seamlessly, with flow, and with lack of complexity, And that complexity dropped the more things you added, appropriate things, and that the value increased as everything you brought. Now, is there anything that we could possibly do as a community which would have more impact than that? That is the next big thing. And the only way that I can see is thinking Ubiety, thinking about the social relationships and the moral order of place, including the societies of people and the society of technologies. If we bring that mindset, then everything we do in the details, we all have to work in different parts of the details, but if we can make sure that we always consider the details we're working on as how they'll contribute to this end, we will advance the technologies and the benefits that it has as a potential much, much faster. And with that, I just say thank you. And I'll just say this. Now that we can do anything, what should we do? Thank you.
Unfortunately, we are way
too long
out of time, but if anyone has a very burning question, then we'll take just one. Okay.
Thank you, Bill, for your wonderful lecture speech. I think Ubiety is the term I'm going to take away from this. I'm Junhyub Lee from Kai Seokhyung Base Lab. Nice to meet you. And my question is, are you glad that this is kind of a small question, but are you glad that the stylus are making a comeback to the ubiquitous computing scene? I mean, if I may quote the late Steve Jobs, I think his famous reaction to his stylus was exactly yuck when he announced the iPad for the first time. And I'm just curious, what was your reaction as a long-time researcher when the iPad did not have the stylus support, and what is your kind of thoughts now that even Apple has Apple Pencil and Microsoft Surface is kind of leading the way?
So, thank you for the question, and I'll give a quick answer as I can. So, first of all, I thank Apple and Steve for such comments because I knew Steve Jobs reasonably well, and I loved throwing things back in his face, and also because we're both competitive, right? And I'll also say that it's really important to recognize that when Steve Jobs said things like that, he's speaking as a marketeer, as a salesperson, not as a historian or not as a technologist. He couldn't do a good pen, so he didn't do one. That's why. Second, Steve Jobs rejected capacitive multi-touch. My group did that in 1984. We published it in 1985. The technology that he acquired to do the iPhone came one step from my group's work at the University of Toronto. That doesn't mean we invented it, because actually somebody had done it before at Bell Labs. He knew about it. He rejected it. He rejected two-handed input, which later he adopted. So he was a brilliant person. He made some very good decisions. But as you'll find, like in photography or painting, the great painters keep 5% of ideas, and that's all they show the public, because those are the ones that worked. But they also made more mistakes. At the 20th anniversary of SIG-Chi, it was said I had more publications than anybody in the history in the first 20 years of Chi. That may be true, but that means I also had more rejections than anybody in the field. And so we just remember what he didn't do and what he knew about. Once you know that, it makes it a little easier. The key thing is that the pen is really important, but the first thing is everybody's being polarized, saying the pen is everything, and it's not. Everything is best for something and worst for something else. And when we adopt something, we must be as literate before making a decision as the good as well as the bad. And then for everything, then find out, then it's about what combinations do we use and how do we get them integrated, and so that you can pick the appropriate tool so I can have a hammer, screwdriver, a nail, and that sort of thing. And it's a fundamental point. And you also have to pay attention what is out there, because the most expensive part of the technology is the investment in skill on the part of your customers. And they can only take a certain amount of change at a given period of time. So when you make the decisions, it's not make you jump from here to there. How do you get from here to there in a reasonable number of steps? So we have to look 3 or 4 horizons down and then take these steps. And learning how to do that, it's a transition in learning, just like the transition in the technologies. Wasn't that short of an answer. But.
Thank you for that.
Yeah, I believe Bill is going to be around during the conference. So if you have other questions, grab him and ask him directly. And let's thank.
Can I make one last thing quickly? A lot of the software that underlies what we're doing is a system called Ambrosia. Michelle's going to have a demo of it, so go talk to him, and he will give you lots of information about the environments and the plumbing that can help accelerate looking into the types of things I was talking about. Then I'm finished. Thank you.
Let's thank him one more time for his wonderful talk.